Okay, take a look at this. How many x-intercepts do we have? 1, 2, 3, 4. We have 4 x-intercepts? Okay. Notice that as if I'm drawing this from left to right, I come down, I cross through the x-axis, don't I? I go back up, I cross through the x-axis. I come down through here, I cross through the x-axis. I go down, I go wiggle back up, and then I cross through. So at every x-intercept, do you agree I cross through?
Yes.
All right. Keep this all in mind because where we're headed here. Now, here's the original function right there. Believe it or not, this factors. You can factor this. We will be able to factor that. I'll show you in a minute. But if you factor it, here are the factors. So we should have an x-intercept at positive 4, right? Because that's what makes this one 0. At positive 4, do we have an x-intercept? Okay, how about this one? At 0, so I have an x-intercept here. And this one, negative 2, that's right there. And then here, negative 3. Yeah? All right. Let's change it around. This time I'm going to do a degree 5 polynomial. Okay, what just happened? I changed something. It's a degree 5. Y'all see the degree 5? It goes more like a cubic function, right? It goes down on the left. I'll zoom out. Right? If I zoom way out, it looks a lot like a cubic function, doesn't it? So the left behavior and the right behavior, it acts like a cubic function. Down on the left, up on the right. But in the middle again, don't we have a bunch of weird stuff happening? Like it goes up and then wiggles back down and back up. And how many x-intercepts do I have? 1, 2, 3, 4? I have 4? Yes? Do I not cross? Where? Okay, so you notice that at 0 something weird's happening? So do you agree right here I cross through the x-axis? Yes, that is an x-intercept because my graph actually touches the x-axis. Then it comes up, it comes back down, it crosses through the x-axis. That's my second x-intercept. I come down, I come back up, and then right here at 0, I actually just touch the x-axis. But I do actually get there. So we have to count it as an x-intercept because I do touch the x-axis. But I don't cross through, do I? I don't cross through. That's the first time this has happened, right? So sometimes what we say is instead of crossing through, I'm bouncing off the x-axis. Or touching. Those two words, you choose whichever one makes more sense to you. All right? So if we're like walking along this graph, we cross through, right? We cross through, then we what? Touch, bounce, whatever you want, okay? Touch, come back, down, back up, and we cross through again. Yes? Take a look at the x-intercepts. We should have an x-intercept at where? 4, we do. We should have an x-intercept here at what? Negative 2, we do. Here we should have an x-intercept at negative 3, and we do. And I saved this one for last for a reason. We should have an x-intercept where? 0, and we do. But that's the one that we touched, right? Does anyone see the difference between these 4 things? What is the power on this factor? What's the power outside the parentheses? 1. What's the power here? 1. What's the power here? 1. It turns out that the power on the factor dictates whether or not you touch or you cross. If this power is even, you will always touch. If it's odd, 1, 3, 5, 7, if any of these are 1, 3, 5, 7, you will cross, guaranteed. All right? I want you to see this first. We're going to define all this in a minute, but I want you to see it at least for the first time. All right, so let's change something. You tell me what would happen. Does someone mind wiping that back down? There's a towel there. Can you wipe that red off there? Thank you. You tell me what would happen with the x-intercepts if I change this right here to an x minus 4 squared. What should happen? I'm going to bounce off at 4 instead of cross through, right? But aren't I also going to increase the degree by 1? Yes? So let me do this. Okay, so now I have a 6th degree polynomial. Notice that this just changed to a 2. Everything else is still the same, right? So I'm actually bouncing off in 2 places. Do you see it? At 0, I'm still bouncing or touching. What do y'all want? Touch or bounce? I'm going to say both. I'm going to say both. I'm touching right here at 0, and I'm touching at 4, right? And the whole thing looks more like a parabola again, doesn't it? What else? Let me kind of start with let me go back to a quadratic. Here's a quadratic function, a parabola. Right? There we go. Good old parabola, right? How many x-intercepts do we have on a parabola? In this one, 2, right? Am I crossing through or am I touching? Crossing. Well, look at when we factor that, what are the powers on these factors? 1, right? That's why we cross. Now, let me change it to a 3rd degree polynomial function. And here's the 3rd degree polynomial function right there. If we could factor that, here are the factors. The powers on each one are 1, right? So we should cross through at all of them, which we do. Now I'm going to change these 2 right here to squares, which is going to increase the power twice, right? So it'll be 5th degree polynomial. Which ones did I say I was changing? I forgot. The first 2? Hold on. I was going to change this one right here and this one right here, right? So I'm going to go... Look at how drastically the graph changed. You see it? So I still kind of look like a cubic function. I'm coming, it's down on the left, up on the right, but I come up, I only cross in one place. On the other 2, I touch, and then I touch again, right? So here's what our goal is for the rest of today and next class, is that we want to be able to graph these. I want to be able to give you a polynomial function and have you graph it. So what I'm going to do, the way we're going to start today is I'm going to give you the polynomial function in this format, because that'll be easy for you to identify the x-intercepts. It'll be easy for you to tell me bouncing and touching. Touching and crossing, right? And then next time I give you the polynomial function in this format, and we have to go from here to here, and that's going to be the hardest part. Because most people have like an AC method or something. How the hell do you factor that? And that's what we're going to spend time on. All right? You understand where we're headed? Oh, let me also point out, because this is going to come up. I know someone's going to ask me this. What we will be able to do in this class is we will be able to determine what the left and right hand sides do. Up, down, we'll be able to determine that. We'll be able to determine the x-intercepts. We'll be able to determine if we cross or touch. What we will not be able to determine is actually how high this goes, how high that goes. We will not be able to find where those peaks actually are. You would do that in a Calculus 1 class. Yes?
So the easy way to tell if what the sides do is by looking at the degree. If it's like a non-degree, it goes up and down. If it's in the degree, they both go up unless the leading coefficient is negative.
That's exactly right. That's the next note right here. It's this is the summary right here. This is called the leading coefficient test, everyone. So what this test is saying is that if somebody gives you a polynomial function, you're going to have a degree, aren't you? You're going to have a degree? And you're going to be able to find a leading coefficient. Because you all said you wanted me to give you a problem, like 30 or 50 of those on a test, right? And everyone said, so you can identify the degree and leading coefficient. This table shows you how that determines your left and right hand behavior. So I'm going to give you an example up here on the board. Let me see. Yeah. Let's just do this. Let's say as an example, I give you a function f of x equals negative x to the 7th minus 3x to the 4th plus 1. What's the degree of this polynomial function? 7. So the degree is 7. What's the leading coefficient? I'm going to abbreviate leading coefficient LC. Negative 1? That's this in front, right? Now go to that table. Is your degree, which is n here, sorry, I should let you know this is n. Is the degree even or odd? It's odd, right? We have an odd degree. Is the leading coefficient positive or negative? It's negative, so isn't it less than 0? So what does it look like? So you know how to read this table? You have an odd degree, so it's going to be one of these two. Your leading coefficient, is it positive? No. Is it negative? Yes. So it's this and this. So it looks like this one. Okay. The degree is odd, right?
Yes.
So you're looking down this column. It's either this or this. But your leading coefficient is negative, which means it's either this or this. So it's both. It's got to be this and this, so it's got to be this one. Odd degree, negative leading coefficient. There's only 4 possibilities.
A sub n is your leading coefficient.
Leading coefficient. This is LC, leading coefficient. All right? So look, polynomial functions, the end behaviors can only be one of 4 things, right? It's this, 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 this. That's it. Right? Thank you. It's the LC, the leading coefficient dance, yes. Why do I have question marks right here?
Because they do wiggly shit.
Yeah, because they'll wiggly shit in the inside. Exactly. That's the part that's going to be hard. That'll be the difficult part. The leading coefficient test, which is what this is the easiest part of the whole problem. You determine the end behavior. It's filling in that question mark in the middle that's tough. All right, this is just talking about bouncing, crossing. All right, so do you remember how I said each factor, if it was squared, it touched, right? If that factor thing was squared, or if it was like even, 4th power, 5th power, didn't matter, that would tell you touch, right? And if it was an odd power, then it would cross, right? That power up there is called the multiplicity of the factor. So that's what this note is about, multiplicities of the 0. So what's the multiplicity of this factor? 2, which is even, right? And if I changed it to like x plus 1 cubed, that multiplicity of this factor would be odd, right? Which means we would do what there? Cross, right? We're going to do examples, okay? I think once I show you a couple of examples, hopefully you'll be okay. All right, let's look at those. Now there's something subtle in here, so please pay attention and ask questions if you have them. First one, f of x is x plus 2 squared. I am first going to try and determine what the end behavior is. All right? What is the end behavior? So is it doing, which of the 4 dances is it doing here? Well, you have to know the leading coefficient and the degree, don't you? Which means you have to multiply all that out, which is a pain in the ass, isn't it, to have to do that? So there's a shortcut. Y'all paying attention?
Yep.
Okay. Remember I said I'm going to start with this, right? That's what I said. I'm going to start with these. They're already going to be factored for you. The harder part's when we have to factor them. The give and the take is that if I give it to you in this form, it's hard to find the leading coefficient and the degree because you have to multiply it all out. But here's the shortcut. This right here is really behaving like an x to the first power, right? Times. Now, if you were to take this and multiply it out, what would be the highest power of x you would get?
2.
X squared, right? It would be actually a 1x squared, because you would do this. See, I don't want us to have to do this, but look at that first multiplication. You would get an x squared, wouldn't you? That'd be the highest power of x you get. So this is behaving like an x squared. If you take an x and you multiply by an x squared, what would you get?
X cubed.
X cubed. So this whole thing behaves like 1x cubed. That's what it behaves like. And if it behaves that way, then what is the leading coefficient? Well, what is the degree here? Degree is 3. The leading coefficient is 1. So go to that table, which
So it'd be the, like the square root function, or the cube root function. Top right.
you have this in your notes, right? So which one, top what?
Top right.
Top right. We have an odd degree. We have a positive leading coefficient. So I already know right now that when I draw this, it's going to go down on the right and up on the left, right? And in the middle, I have no idea. Any questions on that part?
So we just leave it like that, we don't put it on a plane or anything?
Hold on.
What's the 3 odd again?
When you multiply these two together, you add the exponents and you get a 3. So this right here is where that comes from. Is that what you're asking me or no?
No, why is it odd?
Like, why is it odd? I'm not sure. Like, why is the number odd? Like, 3 is an odd number? I'm not sure.
Oh, that's what's not right.
Are you not thinking like even odd numbers? You're just thinking like odd, like an odd person or something? Is that what you were just confusing the word? Okay, all right. Well, that would be confusing if it's, so it's odd as in 1, 3, 5, 7, 9. Okay, all right. I was confused. All right, so we've got the end behavior, right?
Yeah.
Now, can you tell me, who said we're going to graph this? Not yet. Can you tell me where the x-intercepts are for this thing? So this right here, this is called end behavior. Now I'm looking at x-intercepts. So how do you find the x-intercepts of a function? You set it equal to 0, don't you? Well, that's going to be pretty easy, isn't it, to set this equal to 0 because it's already factored. So I set this equal to 0. And now I set each factor equal to 0. X equals 0. And then the other factor is x plus 2 equals 0. I don't have to worry about the square. That just means there's 2 of them, right? If you said each one of them equals 0, you can get the same answer. So what are the two x-intercepts? 0 and negative 2. Y'all okay with that? All right. So I've determined the end behavior. I've determined the x-intercepts are at 0 and at negative 2. I have no questions? The next thing I'm going to do is determine the multiplicity. That's the bouncing, touching, or crossing. I know that these are the two places where it happens, right? It's just a question of do I cross through there or do I touch there? So let's go back and look at where the 0 came from. The 0 came from this factor, didn't it? What is the power on this factor? 1. And 1 is odd, right? 1 is an odd number. So the multiplicity of this 0, I'm going to put mult underneath this. The multiplicity of this 0 is odd. And that's coming from that power right there. And what does odd multiplicity tell us? We cross through. So I'm going to cross. Question. Okay, now let's look at the negative 2. Negative 2 is an x-intercept. It comes from this, right? That comes from this factor. What's the multiplicity of this factor? 2. So the multiplicity of this one is what? even. And what do we do when we have even multiplicities? We touch. You got it? Okay. What the biggest mistake that I see is students will get the x-intercepts, and then to figure out the touching and the crossing, they actually look at this number and they say, oh, well, 0's even. That's not what determines whether or not you cross or touch. It's the power on the factor that generated that solution. So it's a little bit different. Okay, now at this point, we can draw the whole thing. All right? Let's draw it. That's all the information I need to draw the whole graph. So let's start off with an x-axis. And you can put a y-axis. You don't have to. I usually don't put the y-axis, but I'll do it for here. 0 and -2 are x-intercepts. That's where I'm going to start my graph, with the for sure points I know exist on my graph. 0 and -2. Do you all agree? The next piece of information that I'm going to use is the end behavior. So what I know is that the left side of this graph must go what? Down, and the right side must go up. Now, I'm going to very lightly in pencil, so I can erase this in a second. I'm going to say to the left of this point over there, it's got to go down. So it's got to be over here somewhere, right? And very lightly over here, I'm going to say, okay, to the right of this point, I've got to be up like this. Yes? Now, when I draw this and I get to 0, right, that x-intercept, oh, sorry, let's go in order. -2 would be the first one I would get to if I'm drawing this from left to right. When I get to -2, what do I need to do when I get there? I need to touch. So I need to come up from here. I need to touch there, right? Not cross through. Touch, and then that forces me to come back down, doesn't it? So it's going to look something like this, very lightly. I'm just drawing. It's going to touch. It's going to come back down. And then what has to happen? Got to get to 0 and cross through. So when I draw the rest of it, it's going to look like that. See it? Touch, and then come back and cross. Now, all polynomial functions are smooth and curved. They are not like jagged, V's and stuff like that. They're nice like roller coasters, okay? All of these, except for lines. Lines are polynomials and they're straight. But other than that, they should all have a nice, slow curve to them instead of sharp angles. That's why I draw everything very lightly first. Now I'm going to come through here with my final result, which means I'm going to erase this. I mean, if you're happy with what you have drawn, then be happy with it. But now that I'm definitely sure what it does, I'm going to do this. Okay, there it is. Now, everybody's graph is going to look different. Someone else might draw this like this. Right? Someone might draw it like that. Agree? Someone might draw it like this. But is it wrong? It's not wrong based on the information we have. Right? They're all okay. And like I said, what you cannot determine in this class, what we will not be able to determine, is how low this goes. We don't know. What we do know is that between here and here, the function is what? Negative. And then over here, it's also negative, right? And then over here, it's what? Positive? We don't know how positive, we don't know how low, and all that stuff. You wait till calculus and you can determine these points. It's called finding the maximum and minimum of the function. With the parabola, we can do it, can't we? It's the vertex. But that's a special formula, and I told you that comes from calculus. But once you get past the quadratic, it gets very difficult to find these. Okay, so let's say for homework tonight, okay, do not do what's on here, all right? Don't do what's on here. I want you to do 2, 3, and 4. Those notes are online, yes. Do 2, 3, and 4. So I want you to graph those. I want you to turn those in at the beginning of class next time. I want you to turn those in at the beginning of class next time. I want you to turn those in at the beginning of class next time. 2, 3, and 4.
Are you going to put it on Canvas?
That's from a movie. There's some movie where someone makes someone promise him something. It's like, promise me. And then he says, I promise. And then he's like, promise me. And he's like, I promise. Is it Fight Club? It's like, okay, that's 3 times he promised. Yeah, that's right. All right. Y'all understand? Have a great day. I'll see you on. You will have to do the homework out of this section, just not yet. All right, I'm gonna hold you off on it for